Alright, hey guys, this video is part 6 of our review of Introduction to Polynomials. We've done all of this stuff already. I'm not going to list it because it's just too long. Just know that there were other videos on a bunch of other stuff. And so you can check the playlist if you're watching this on YouTube. But we are factoring, and we are finishing up our factoring section by talking about what to do if you have higher powers, like fourth power. And this is not new. I'm going to show you that you already know how to do this. Alright, so this looks new because it has the fourth power, but it really is not new. You see that it's a trinomial. Okay, normally when we have a trinomial, the first thing we look for is a common factor. There is no common factor. So the next thing we do is we see if we can factor it as a binomial times a binomial. Now, just as a shortcut to help you see when this is going to be possible, if you have a fourth power and then squared and then a constant, that's when this technique is most likely going to work. But really, if you see a trinomial, just try to factor out the GCF, and then go ahead and try doing your binomial times a binomial procedure like we always do. So check it out. Start with x to the fourth power. We always start with that first term. And ask yourself, well, what times what will make x to the fourth power? Alright, hopefully you're thinking, well, x squared times x squared will make x to the fourth power. Then jump over to the last term, alright, 49. Technically, there's two ways to make 49. It could either be 7 times 7 or 1 times 49. My money's on the 7 times 7. Okay, so let's try the 7 times 7. Okay, next we start thinking about the middle term. The middle term is negative 14 x squared. And we have learned that the inner plus the outer has to equal the middle. Okay, now the inner is this, the outer is that. Okay, so inner I have 7x squared right now. Outer I have another 7x squared. Is there any way I can get a negative 14x squared out of this if I pick the signs right? Sure. If both of these were negative 7, that would get it done. So that would make both of these negative 7. Check one last thing. Are we getting a positive 49 out of this? Well, yes. Negative times a negative is a positive. So this is the answer. So even though it was fourth power, I hope that you're seeing that you could just follow the normal procedure that we always do for trinomials, and it factors just fine. The only thing to watch out for is every now and then one of these factors will itself be the difference of two squares. Okay, like look, check this out for a second. Let me just cut and paste. Okay. Wow, that's cool looking. Alright, now imagine for a moment that instead of having x squared minus 7 times x squared minus 7, let's say that it had been 9. Okay, let's say we had gotten x squared minus 9 and x squared minus 9. Okay? Well, these are the difference of two squares. So we would have to keep going. Okay? We'd have to go, each one of these would split up further. So x squared minus 9 is x plus 3 times x minus 3. And same thing with this one over here. x plus 3 times x minus 3. So then this would be our answer. So that's the only thing about the higher power. Sometimes you'll get something that can factor more. Now, let's say if only one of these had been minus. So say if this had been a positive, x squared plus 9 and then x squared minus 9. Then this one over here would factor more, but this one wouldn't. Okay, because you can't factor the sum of two squares. So in that case, you would have just kept this one the way it was. And then this would be your final answer. Okay, so that's the only thing to watch out for. But in this case, we were done right here. Alright, I need to show you that this is really just the difference of two squares. Now, you're familiar with the difference of two squares. If I have x squared minus 36, this is the difference of two squares. You can immediately tell me how this is going to factor, right? Go ahead and say it out loud. That's right. X plus 6 times x minus 6. Alright, so what I need you to understand is if you have the fourth power, let's see, I can't choose my colors. Say if I had x to the fourth power minus 36. This is still the difference of two squares. Alright, any even power is a perfect square when it comes to variables. So this would just be, well, you tell me, what times what makes x to the fourth power? Yeah, this would just be x squared times x squared. Okay, so I could do x squared plus 6 and x squared minus 6. Okay, so just because it's a fourth power, it's still the difference of two squares, so you can do it. Alright, but watch out for one thing. Let's say I had x to the fourth power minus 16. Then this is the difference of two squares. So I would have x squared plus 4 times x squared minus 4. Alright, but the thing is, one of these is itself a perfect square. Do you know what I'm talking about? Okay, I guess I can't just do that. Let me try this then. Oh, that's cool. This one that I just highlighted in yellow is itself the difference of two squares. So what you would need to do is continue. So this would be x plus 2 times x minus 2. Alright, you have to continue to factor it. And then this part, the x squared plus 4, you can't factor the sum of two squares, so you just bring it down unchanged, x squared plus 4. So this would be your final answer. Okay, so that's the only thing you have to watch out for when it's fourth power, because sometimes when you do your difference of two squares, you'll get another difference of two squares, and you have to continue. Okay, so getting back to this problem, this is the difference of two squares. So this would be x squared plus 1 times x squared minus 1. Okay, now is this a problem where we can just stop here, or is this a problem where we need to keep going? This is a problem where we need to keep going. Let's see if I can just grab just this one. No, not exactly. Alright, I think I wanted to make this red. But I'll have to do this to fix it. Okay, this red one is itself the difference of two squares. So we're going to have to keep going with it. So x squared minus 1 will further factor as x plus 1 times x minus 1. Okay, the blue factor is unfactorable because the sum has to be the difference. So we'll just bring this one down. So that'll be x squared plus 1. Alright, so this will be the final answer for number 23. Alright, this brings us to the last concept that we learned, solving equations by factoring. Okay, and to solve equations by factoring, we're going to set the make sure the problem is set equal to 0, and then I'll take it from there. Please understand that you have to, the most important thing is to know the difference. Know when we're solving and know when we're just factoring. So you can go by the directions. You know, if the directions say factor, well, I guess there aren't really directions right here, but you know, I mean, you have the title of the whole category is all about factoring. But if the directions just say factor, then we're just factoring like this, and we stop. Notice there's no equal sign anywhere in this problem. It's not equal 0, nothing. There's no equal sign, and the directions would just say factor. So we just factor and we stop. But notice on this problem, there's an equal sign here. So if you see an equal sign, then we're not going to just factor. We're going to factor, but we're going to keep going. And the directions would say solve. So this is what you do when there's an equal sign and it says solve. So please keep them straight. Okay, so it's already set equal to 0. So let's go ahead and look for the GCF. So there's a common factor of x, so let's definitely bring that out. So we have x, and you know what, I want to do that in a different color. Okay, so we had a common factor, it's x. And that's going to leave 4x squared plus 4x plus 1. And it's still all equal to 0. So now we've got this trinomial. Alright, so we're going to go ahead and try to factor it like we always do. And we have this GCF of x that we pulled out. That's not going anywhere. Make sure you bring that down. Now, looking at the 4x squared, please understand that this 4 has two possibilities. Okay, it's either going to be 2 times 2 or 1 times 4. Okay, I'm going to start with the 2 times 2 option. So 4x squared could factor as 2x and 2x. If this doesn't work out, I'll come back and try the 1x and 4x option. Now, looking at the 1, next, there's only one way to factor 1, and that's 1 times 1. So this should be relatively easy. Please remember the key to all of this is that the inner plus the outer must equal the middle. Okay, the middle is positive 4x. Okay, when I talk about inner and outer, this is inner and this is outer. So right now, inner, I have 2x. I'm multiplying these. Outer, I have another 2x. I'm trying to get positive 4x out of this. Can I get positive 4x if I pick the signs right? Yeah, both of these would have to be positive. That means both of these would be positive. Is that giving me a positive 1 here? Always got to check that. Yes, positive times positive is positive. So we have factored it correctly. Alright, let me get this stuff out of my way now though. Alright, now that we have it factored, because this is not just a factoring problem, alright, please don't stop here. Alright, if there were no equal sign and the direction said factor, we'd be done. But you see an equal sign, you see the direction say solve, so you keep going. Please keep that straight. That's the common mistake kids make. Anyway, so what you do is you set each one of these factors equal to 0 and you solve. Okay, if any of these equaled 0, they would wipe everything out and we'd get 0. So we're going to have 3 solutions. Okay, You know what, I'll just stick with purple. So on this side, if you set x equal to 0, well, that's one solution right there. Right here, if I do 2x plus 1 equals 0, then you know that's minus 1. So 2x equals negative 1. Divide by 2 on both sides, so you have x equals negative 1/2. No decimals, please. So that's a second solution. And if I set this equal to 0, well, it's the same thing. Okay, I'll just write it down. So 2x plus 1 equals 0. I'm going to get x equals negative 1/2 again. If you're making an answer key or something, you don't need to list these twice. Okay, you've already got the negative 1/2, so you don't have to write this one down. Okay, so this one has two solutions. But in general, be aware of this. The degree tells you how many solutions you might have. Alright, so since the degree was 3, we're looking for a possible 3 solutions. And the only reason why it turned out to be 2 is it was a coincidence that this one was repeated. Okay, but otherwise, if the degree is 3, there could be 3 solutions. If the degree is 4, there could be 4 solutions. If the degree were 2, there could only be 2 solutions. Okay, let's do, this is the last problem of our review. Okay, we need to set the entire problem equal to 0. So that means we need to add 5x to the third power to both sides. Okay, that way that'll cancel out and we'll get 0. So on the left side, these aren't like terms or anything, so I'm just going to write them next to each other. So I've got x to the 4th power plus 5x to the 3rd power. And now that's equal to 0. So let's factor this like we always do. Let's look for a common factor. The GCF is x to the 3rd power. So if I pull that out, then I'm going to have x to the 3rd power in the front, and then that's going to be times x plus 5. Okay, now I'm going to set each one of these factors equal to 0. So x to the 3rd power could equal 0, or x plus 5 could equal 0. Okay, well, the only way x to the 3rd power is going to equal 0 is if x itself is 0. So that's one solution. And of course here, subtracting 5 from both sides, x equals negative 5. That's another solution. So we could have had up to 4 solutions. But because this one turns out to be a triple, this is like 0 times 0 times 0, then we only have 2 solutions on number 25. Alright, that is it. We have reached the end of the line. Okay, I hope this review has been helpful. Please make sure that you can do every problem, all 25 of these problems, by yourself. If you had trouble with any of the problems in this review, then I recommend going back to the previous videos. This is day 13. Go back, look at day 1, day 2, day 3. Find the section that had the type of problem that you're struggling with and redo an entire worksheet of that type of problem, and checking your answers and watching the video as needed. Okay, 1 or 2 problems from each type is not enough practice if you're having trouble. If you're getting them all right, no sweat. But let's say you were messing up the grouping. Well, then you're going to go back to day 11, and because day 11 was about grouping, and redo the day 11 worksheet and until you can get them right consistently. Okay, good luck, and I will see you. This is the end of this entire unit. So I guess I'll be seeing you in a brand new unit on the next video.